Hey guys, welcome back to another maths lesson. It kind of sucks because I really wanted to do this one face to face, because I think a lot of people in this class will find it really interesting. So let's instead do it online, and you can just see my face. So far, all you guys really know about trigonometry, or I guess think of trigonometry as, is as the study of triangles. Like you think of trigonometry and you think, oh, right angle triangle, I need to find the side or angle. And yeah, I guess that's all right for the time being. And it does have a lot to do with triangles, but it's a little bit limited when you strictly think of trigonometry in terms of triangles. Now, we've started to kind of move away from it, and we've started looking at the different relationships between like sine, cos, and tan and stuff, and we figured out that, you know, sine and cosine are pretty related, not just by their name, but by the fact that if I had sine 40, then that's the same as cos 90 minus 40, or cos 50. So we can kind of say that they're very linked. And we also said that, let's suppose I had a trig ratio, that there are some exact ones. Exact being, if I had sine 30 or sine 45 or sine 60, then they actually give me nice numbers. So a half, and 1 on root 2, and 3 on root 2, root 2 on 3, root 3, one of them, root 3 on 2. But they do give me nice numbers. And we're a little bit limited in that because we're talking about a triangle, at the moment we can only talk about angles that can possibly happen in a triangle. So 30 can happen in a triangle, 45 can happen in a triangle, 60 can happen in a triangle. Now, what about 0? You can't have a triangle with a 0 angle, that would just be a straight line. Is that a triangle? I don't know. What about 90? If this was 90 and this was 90, what on earth is that going to be? Well, this is also going to be a straight line. What about angles bigger than 90 or less than 0? Does it even make sense to talk about an angle that's less than 0? Well, if I'm strictly talking about triangles, then no. But if I'm trying to move away from triangles, then yeah. So trigonometry makes a little bit more sense, maybe a little less sense, maybe a little more sense if we start using shapes that aren't limited by its geometry. Now, we only talk about right angled triangles, but what if we started talking about triangles that weren't right angled? So, in other words, if I had a triangle here and I call this theta, what if instead I had a triangle that was like this, and it was obtuse, and this theta here was bigger than 90? Then it would work. But I can't really do that because I only look at right angle triangles, and then I look at opposite and hypotenuse and stuff, so it's a little bit limited in that as well. So, end of story, triangles are a little bit limited. So let's move on to something that helps us a little bit more, and it's actually a circle. So what I'm going to do is I'm going to draw a Cartesian plane. Everything I'm about to show you is stuff you already, I guess, deep down know, which is kind of the theme with this topic. Like, you already know this stuff, but I guess you just haven't been shown. I'm going to draw a circle on my Cartesian plane. If anyone guesses the music that is playing, damn it, it says it up there. Okay, here's my unit circle. Now, let's draw a right angle triangle in it. So, boom, boom, boom. There's a right angle triangle. Let me show that it's right angle by putting a right angle in it. Okay. Let's call this point something. How about XY? That'll do. Now, I've got a right angle triangle, which is, I guess, our basis of trigonometry, and I've got a unit circle. Oh no, I've got a circle. I've got to define it to be, let's make this really easy, and let's say, okay, this thing has a radius 1. So in other words, this cuts at 1, that's minus 1, that's minus 1, and that's 1. That would tell me that this length is also 1, because it's the radius, which is also the hypotenuse. So this here is called the unit circle. Unit meaning 1, circle meaning a round shape. Okay, now let's start using trigonometry on this. We know sine, cosine, and tangent, they're things. Let's start defining them. Well, I've got a right angle triangle. I need to define an angle. So let's put one here, okay? And we're actually going to define this angle as, so starting here, our angle's going upwards, like that. So it's this angle. I'll explain why I said that in a sec. So sine theta, cos theta, tan theta. Let's figure out what they are. Now, sine theta is opposite over hypotenuse. So I probably need to name these two sides. Well, this is the x direction. Let's just call this x. This is the y direction. So let's just call this y. Now, what did I say? Sine was opposite over hypotenuse. Y over 1. Pretty sure something over 1 is just y. Now, isn't this kind of interesting? We've just said that this y value, I can just rewrite that as sine theta. Let's look at cos. Cos is adjacent over hypotenuse, so x over 1, x over 1. Pretty sure that's just x. That's kind of strange because that allows me to rewrite this coordinate. Instead of telling me how far across and how far up it is, you could just tell me, well, here's my angle. Let's do cos of it and then sine of it. So this was like cos theta, and this is a sine theta. So really, I can rewrite this as cos theta, sine theta. This is actually used in extension 1, and this is used in engineering. This is used in resolving forces, which just means that if I've got forces in certain directions, I can describe them using the angle and cos and sine. So if anyone's going to do engineering, if that gets through, then you'll be definitely using this. But it all just comes down to trigonometry. Okay, might as well do tan while we're here. Tan is adjacent. Oh, no, it isn't. It's opposite over adjacent. So y over x. And this spawns our first couple of relations. So our relations being these three, which just means sine is my y coordinate and cos is my x coordinate. Tan is y over x. Now hang on, isn't y over x, doesn't that equal sine over cosine? There's our next result. These were just weird things that come out of trigonometry, and it might not have been easy to see them if we hadn't related things to our unit circle and our Cartesian plane. So trigonometry actually, we'll get there. Okay, that's the first thing I want to show you. The second thing is we've already looked at complementary angles. Let's look at supplementary angles. Oh no, let's not do that. Let's do this first. So remember before when I was saying, okay, well I've got, so suppose this was my triangle and that was 30, and suppose this was my triangle and that was 45, and then suppose this was my triangle and this was 60, and those three things have exact values. That's what we discussed last lesson. So like sine 30 was a half and cos 60 was a half and stuff like that. Now, if I want things, maybe I was kind of foreshadowing before the 0 and the 90. Let's investigate that a little bit. And this all comes from our definition here. So let's suppose I wanted to know what this coordinate is. So let's do it in a green. What is this coordinate? Well, that's the coordinate 1, 0, 1, 0. Okay. But let's talk about it in terms of sine and cos. If I know that this angle here is from the x-axis going around, if I'm looking at this point, so remember here that I've drawn, so I used this point before and I drew a line to it. If I was using this point now and I drew a line to it, what is my angle from the x-axis to this line? This is where I'd ask you, but obviously that, well, maybe not obviously, but it's 0. Like I'm starting here, I'm trying to go around to this at 0 degrees. So what I can do instead of saying 1, 0, I can say cos sine. What's my angle? So what's my thetas? My theta here is 0. The angle is 0. Cos 0, sine 0. So this actually tells me what cos 0 and sine 0 are. So have a look at this. Cos 0 is 1. Let me use XL's calculator. Cos 0 is 1. Isn't that interesting? What do you reckon sine 0 is? Well, we've already defined it. Sine 0 is equal to 0. And that's using this. So now I've got 30, 45, 60, and I also have 0. So these are my 4 special angles. Let's come up with a 5th one. Let's have a look at this point here. What coordinate is that? Well, that's 0 across up 1, 0, 1. So let's talk about it in terms of cos and sine. What's the angle? So remember, I'm starting from here and I'm going around to here. Well, I'm sure that's a right angle. So in other words, it's cos 90 and sine 90. That's it. So cos 90 degrees is 0 and sine 90 is 1. So let's look at that. So sine 90 is 1 and cos 90 is 0. So that's our next ones. Do I want to write those results? Sure, let's go results. So what have we got? We've got sine 0. Oops, that's not a 0. Sine 0 was 0. Sine 90 was 1. Cos 0 was 1. Cos 90 was 0. Okay, we've got sine and cos, might as well do tan. Let's think about this. We don't actually need, we don't even need to look at the circle anymore. Let's look at this. I know that tan is sine over cos. So in other words, I've done this wrong. Let's draw it. Let's move this. Okay, let's go tan 0. Well, tan is sine over cos. So tan is 0 over 1. So 0 over 1. 0 over 1 is just 0. Okay, let's move that underneath. Now, this is what I was trying to show you, Alex, yesterday. Again, tan 90, given they're the same angle, it's sine over cos. So 1 over 0. Now, if you type in 1 over 0, I'm pretty sure you get a math error. If you ask Siri, undefined. So, in other words, tan, I can't tell you what the ratio is when it's 90 degrees. Now, what I have here is, well, actually, let's keep going. I've done these 2 points. Why don't we do this one? That's the coordinate -1, 0. So let's figure out what cos and sine is. Cos, sine. Okay, now I'm starting here and I need to hit this line. So I'm going around. What angle is that? That's 180 degrees. So that tells me that cos 180 is -1 and sine 180 is 0. A couple of reasons why you might think this is strange. The first one is, why am I ending up with a negative? Every time in trigonometry so far, you would have been looking for an unknown side or an unknown angle. Not once would you have seen an unknown side that was a negative value. And that's kind of what I was talking about in terms of trigonometry being very limited by a definition of triangles. So it doesn't really make sense to talk about a distance that's negative. But in a unit circle or a Cartesian plane, it certainly does, because most of our coordinates, mainly all these, there is some negative coordinate, like an x or a y. Now also, 180 degrees, we can't fit 180 degrees in a regular triangle, especially a right angle triangle, because if that's it and that's 90, these have to add up to 90. It's no way that they can get to 180. So you can see that our definition has been very limited so far. Oops. Let's keep going. Let's have a look at this one. Just for fun. I don't think I even have to show you this. So this is 0, -1, cos, sine. Now what's this angle? So we're trying to get to here. We're starting on here and going around. That's 270. 270. So if I type into the calculator sine 270, I should get -1. So sine 270, I should get -1. Cool. I want to show you what I was talking about last lesson in terms of when I was in year 11. This is the table that I made. So this was to help me remember. So in the yellow here, that was the stuff that I was showing you last lesson with the half, root 2 on 3, root 3 on 2. And then I've got degree 0 is, so sine 0 is 0 and sine 90 is 1 and stuff like that. So I use this to remember. Anyway, let's get back to it. Now I've got my results. I've got my results for 0, 90, 30, 45 and 60. Now we've only really touched the surface still. Let's look at supplementary angles. Supplementary angles. Alright, in order to look at these, I'm going to draw a new unit circle because my one up there is getting pretty messy. I don't like where that is. There. Not that. Okay. Now, I know that, let's leave this in there. I know that this point up here is xy. Yeah? And I also know that it's cos theta, given that's theta, sine theta. That's what I've looked at so far. What I want to be able to do is, at the moment all I've been able to do is all the values in here. So remember 30, 45, 60. I know 0, I know 90, and now I know 180 and 270. No, I haven't looked at 360. Here's a point. This value here, I can call that either 0 or I could call it 360. So I want you to see what happens when you type in sine 360. Do you get 0? Cos 360. Another thing, I'm going too far now, but I don't care. If I go around 360, what's stopping me from going around again? What do you reckon cos, oh my god, what, 720? What do you reckon cos 720 is? I think about that. Also, what's stopping me from going backwards around the circle? What would I even put here? Food for thought. Okay, supplementary angles. Now, supplementary means 180. Maybe I should write that somewhere. 180. So what we're basically going to look at is, I know what this is. What do we think this is? Knowing that this is also theta. So this is where we come up with our newest results. So we had our complementary results, and our complementary results were sine theta equals cos 90 minus theta. There are complementary results. Now we're going to look at some supplementary results. I think I might need, I'll skip something. Oh well. Okay, our supplementary results. Let's actually call, should I call this something? Yeah. Let me draw my triangle. So this is y, that was x. Okay. What's this value here? Before we say it, what am I trying to say? How do I put this? Okay. How do I write this?
Gotta relax.
Yeah, we'll leave it. Mr. Backhouse. Okay. Let's look at our y coordinates first. So our y coordinates being sine. So let's suppose I know what sine theta is. So remember, sine theta is my y coordinate. So sine theta, y coordinate. I know that that's y. Okay. Now, I kind of define this two different ways, because I've said that if I've said that this is theta and I'm looking at this triangle, then it doesn't really make sense for me to talk about this triangle all of a sudden and start trying to define stuff. What I'm going to do instead is talk about, so remember how, I'm going so off topic, remember how we start here and we go around? If I'm trying to define this point here, what I need to do is start here and go around. So this is what I was doing before. Now, in order to do that, now I'm looking at this angle here, okay? Now, what that angle actually is,
Global X is a legal technology business.
Oh no, my video's got an ad.
They'll generate an electronic
Skip. Thank you. What's my calculator on? There we go. Okay. Now, I do know that that's theta. If I want this angle here, I need a way of talking about it in terms of theta. Now, I know that this little part's theta. How do I define all the rest of this? Well, that's actually 180 degrees minus theta. So that's 180, take away theta. So that means this green angle is, so that angle is 180 minus theta. So now what I can do is I can relate this line and this line. Okay, so that tells me that sine 180 minus theta, well, what's that? Well, let's have a look. So remember, sine is just the y coordinate. So if I'm looking at this line here, what is the y coordinate here? Well, it's actually the same as this. These two things have the same y coordinate. So this thing here is y. So in other words, this is y. So in other words, therefore, if I know what theta is, then that's really the same as 180 minus theta. You might not think that's important, but let me show you why you might use that. Let's suppose I knew what theta was. Let's suppose this was 45, and I want to know what angle this had to be, for instance. Well, sorry, not that angle, this angle. Well, now I would know that because I know they have to be the same thing. So if that was 45, then this would be 180 minus 45, which is 135. So that basically tells me that this is 135. Why does that matter? Well, I know what sine 45 is. Sine 45 is equal to 1 on root 2. Sine 180 minus 45 is also equal to 1 on root 2. So that means sine 135 is also equal to 1 on root 2. So you can see that if I was just asked, tell me what sine 135 is, I wouldn't be able to do that because I don't know. All I know is that 30, 45, and 60 are nice numbers. But actually 135 is also a nice number because it's 180 minus one of my nice numbers. I said nice numbers a lot. But this is kind of where we're going. And you can see that on my sheet, it goes 30, 45, 60, 90, 120, 135, 150. Like these things go around the circle. So in other words, there are nice numbers for pretty much 30, 60, 90, 120. Like if I go up by 30s, or I go up by 45s, or I go up by 60s, I'm going to get all these nice results. So this is allowing us to start developing more results, I guess. Okay, we've only touched the surface. That's only sine. Now, let's try cos. Maybe I should put a box around this so I don't start losing the important things. I apologize in advance. This is going to be a long video. We're not done yet. Alright, let's look at cos. So cos theta equals. Now, let's just use the same thing. I know that cos theta is x, right? So cos theta being my x coordinate. If I'm now looking at this one, which is my supplementary angle, so it's 180, it's like a reflection over the y. I know that cos theta is x. Then what is cos 180 minus theta?
Gotta relax.
That's what I'm trying to figure out. So 180 minus theta being this angle here. So basically, here's my point. What's the x coordinate of this point? Well, if that's x, then this has to be minus x. It's just x in the negative direction. The reason this was positive y is because they're both like the same. They both have the same y coordinate. So like this point, maybe I should write what this point is. This point is minus x y, which is cos 180 minus theta sine 180 minus theta. So in other words, this is minus x. What does that tell me? Well, that tells me that cos theta is equal to minus. We just had an ad, are you kidding?
generate an electronic contract of sale. They'll send that contract.
What are we looking at? DocuSign. Cool. Don't care. Okay, that's our next result. So this one. Make a box. Thank you. That's not a box. That's trapezium. There we go. Okay, that's our second result. Maybe the more important result of these. Alright, we've done sine, we've done cos, should we do tan? I guess so. I don't need the circle for tan, because I know how tan and cosine and sine relate. I know that, let's move this. Move this here. I know that tan, this could be our first example. I know that tan theta is equal to sine theta over cos theta. So the good thing about tan is I don't actually, a lot of the time, have to do a lot of these calculations. Now, I want to know what tan 180 minus theta is. Well, that's just sine 180 minus, so actually let's keep going. This is y over x, okay? So sine 180 minus theta cos 180 minus theta. Right. I really hope I'm not losing people. If I am, I apologize. Now, let's move this. This is equal to, so what was sine 180 minus theta? Well, that was the same as sine theta. See, sine theta, sine 180 minus theta. So this is just y. Now, cos 180 minus theta was minus x. So that means this is minus x. Okay. What does that mean? Well, that is the same as minus y over x. So I've shown people this before. If you ever have a minus in a fraction, you can put it anywhere. The minus can go here, can go here, can go out the front. Who cares? Now, if I've got minus y on x, what is y on x? That's just tan theta. We said that here. So in other words, tan theta equals minus tan 180 minus theta. Okay, we've got our results. Whoops. Again, you might be thinking, why do I care about these results? Well, for starters, that's rude. Secondly, advanced maths. Thirdly, let's look at some examples. Okay, let's actually do an example. Let's see what, okay. I know tan 140 is equal to minus tan theta. Find theta. That's my question. Now, this is a little bit vague because if we look at our unit circle, theta could be anything. Like theta could be here, could be here, could be here, could be here. So what the question is going to do is say theta is acute. What does that mean? Well, that means I'm strictly looking here because that's the only part where theta can be acute. So think about here, it would be obtuse. Even I know this is theta, but we're talking about this angle. And if I kept going, which I'm not going to, but if I did keep going, I can start looking at these and these. In year 10, we only look at these two. In next year, we're going to look at all four. While we're here, actually, this is called the first quadrant, because it's kind of like where we start. This is the second quadrant. This is the third quadrant. And this is the fourth. Okay. Anyway. Okay, find theta. Well, there's a couple of things that I know, and it's maybe I'll write what I know. I know that tan theta is equal to tan 180 minus theta. Actually, it's equal to negative that. So that's what I know. So in other words, I've got an angle here that's, so 140 is in this quadrant, yeah. So what I can say is, well, I know that 180 minus 40, 140 is equal to, oh my goodness, is equal to 40. So how does that help me? Well, what I can start doing is talk about what is theta. So in other words, tan 140, I'm pretty sure that's the same as tan 180 minus 40. They're the same thing. Now, all I've done is rewritten what this middle part is. So tan 140 is the same as 180 minus 40. So now, if I thought of this as theta, so as this theta, then I can start making comparisons. So in other words, this is equal to minus tan 40. So I basically call this theta and this theta. And I know that that's positive and that's negative. That's positive and that's negative. I don't feel like I explained that very well. I apologize. This is gonna get quite confusing. Okay. Sine 100 is equal to what? Alright. Instead of saying that, let's compare it to theta. What's theta? Okay. Well, do the same thing. I know that sine 100 is sitting in here, so let's compare it to its angle here. So pretty much what this is saying is sine 100, let's suppose this angle here is 100, then what's this angle? That has to be 80. So that's kind of what I'm comparing it to. So I can rewrite this as sine 180 minus 80. That's the same thing, yeah? Okay, but that's equal to sine 80. You see, because that's theta. If I call that theta and that theta, remember from up here that sine theta is equal to sine 180 minus theta. So sine 80 is equal to sine 180 minus 80. I hope this is making sense. If this was cos, then my answer would just be a negative here, because it's the negative. So I don't know how else to explain this. Cool. Let's try another one. Okay, I've got cos 120. That's equal to minus cos theta. What's theta? I'm assuming these are acute angles, by the way, but we'll get to that. Okay, I want to relate cos 120. So basically, I'm looking at this angle here, that's 120. So what's this angle got to be here? Well, that's got to be 60. So in other words, I haven't even answered the question. That is 60. Oh well. Okay, so that's the same as cos 180 minus 120. I haven't written that any differently. Okay. So I have. Okay, so this is equal to this. So basically, that's theta. Now I can write equals minus cos 60. And also think about this, I know what cos 60 is. I know what cos 60 is. It's a half. So basically that told me that cos 120 is a half. Shall we test that? Cos 120. Minus a half. Oh yeah, I've got a minus a half. Cool. I hope this is kind of cool. Like this stuff, I feel like this stuff is cool. I don't want to scare people. Holy, we've written a lot. Okay, let's do a couple more. Where am I going to fit these? I'm going to take a new page.
Gotta relax.
Okay. What question have to 4? Let's just start writing stuff. Like what's sine 120? Tell me what that is. Let me just do that. Oh. Okay, sine 120. What does this equal? Well, let's work it out. So, sine 120. So basically we're saying this angle here is 120. What's this angle? Well, that's got to be 60. So basically sine 120 is the same as sine 60. Because sine 180 minus theta is equal to sine theta. So basically if this and this add up to 180, then you're good. See how this and this add up to 180, then they're the same. Now I know what sine 60 is. That is, according to my trusty sheet over here, it's root 3 over 2. So before, or last lesson, I would have asked you, okay, what's sine 60? Well, that's root 3 on 2. Now I'm asking you, what's sine 120? Well, that's also root 3 on 2. Alright, last question. Tan 135, what's that? Well, back over here, 135. This angle here is 45. As soon as you see your other angle as being either 30, 45 or 60, you're golden. Or, as soon as you see a question with this, and you know that 135 is a multiple of 45, or 120 is a multiple of either 30 or 60, like if you ever see 30, 45 or 60, you know that your answer is going to be nice. So tan 135, that's the same as, looking over here, it's the same as minus tan 180 minus theta. So minus tan 180 minus 135. This is minus tan 45. Okay, now tan 45, I actually know what that is. Do I? Tan 45 is 1. Check our answer. Tan 135 minus 1. Go. I feel like I've worked these out really stupid.
This is Earth Radio. And now here's human music.
I've probably done these backwards. Maybe it'd make more sense to do this.
Human music.
So if I was asked what sine 120 is, just rewrite that as sine 180 minus 120, which is sine 60, which is root 3 on 2. Oh my god, why didn't I just do that before? Yes. Okay. Ignore what I said for 1, 2, and 3. What I was saying was very stupid. Let's do another one. 6. Let's do another 2. 7. Okay. I'm gonna make these up. No, I'm not gonna find them. No, I'm gonna make them up. Okay, what's sine 150? Sine 150. We'll just rewrite that as sine 180 minus 150. That's equal to sine 30. And I know what sine 30 is, that's a half. Let's figure out what tan 150 is. I know that it's minus 180 minus 150. That's minus tan 30. And I know what tan 30 is. According to my sheet, it's 1 on root 3. Oops, daisy. Let's look at cos 150. Well, that's equal to cos minus cos 180 minus 150. That's equal to minus cos 30. And cos 30 is root 3 on 2. So minus root 3 on 2. Okay, I seriously apologize for the way I was working out the last two. That was very confusing. Okay, the very last thing I'm going to show you is, I'm sure you've heard of a sine wave. I hope. Sine waves are used in like frequencies and stuff. I'm actually looking at a sine wave now when I'm talking on a string. But I want to show you, where is it?
Gotta relax.
I want to show you where a sine wave actually comes from. It comes from the unit circle. So you can see that the unit circle has so many applications, it's not funny. Okay, here's my unit circle. So my angle is alpha, and I'm moving it around. So that's my unit circle. I want you to think about, and I'm going to put my unit circle up here. And I'm going to show both of these. Can you move there we go, kind of. There's my unit circle. And there's the units. Oh, you can't see the bottom of that. That's triggering. Oh, come on. There we go. well, I guess we're using that one. Look at me, boomer with the technology. Okay. Alright. This is how we're going to generate our graphs. So this is kind of a sneak peek into nonlinear relations. Now, what a sine, I'm sure you've heard of a sine wave before. It kind of looks like this. But where does that actually come from? It comes from the unit circle. So the unit circle, obviously my angle's going around. Once you think about when my angle starts here, remember that sine is the, so looking, I'm going to show a second. Sine is the y coordinate. So just keeping that in mind, sine is the y coordinate. What happens to the y coordinate as this goes around the circle? So the y coordinate starts at 0. I'm going to turn on the graph of this. The y coordinate starts at 0. And then what happens is it goes higher and higher and higher. So look at the y coordinate this here. It's going up and up and up until it gets to 90 degrees. When it gets to 90 degrees, that's as high as the y coordinate goes. So then it starts going downhill. So the y coordinate starts going downhill, downhill, downhill until here at 180 degrees. If I can get it on there, close enough, it gets to 0. And then what happens as it keeps going around the circle is the y coordinate's now going lower and lower and lower until it gets to 270 degrees around the circle, and then it goes up again. That was too fast. That's a sine wave. That's how the sine wave is generated. It's generated using the unit circle. Let's have a look at the cosine graph. The cosine graph is the x-coordinate. Now the x-coordinate starts over here at 1. So the x-coordinate starts over here at 1. So remember, cos is the x-coordinate. Let's watch what happens when it goes around the circle. So the x-coordinate's actually going closer and closer to 0. So think about like x is going this way. It's getting closer and closer to 0. And closer and closer to 0. When it gets to 90 degrees, it is 0. Then what happens is it goes further away, so towards -1. So now it's going minus, 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 -1. At 180 degrees, it's at minus, and then when we're going this way, it starts going positive, positive. So the graph just goes up from there. So a cosine graph is like the same. What I think people might find interesting is what actually happens to the tan graph, and the only real way to think about it is in terms of y over x. So just remember that tan is y over x. What actually happens? Well, it starts at 1, so y over x, the y coordinate's 0, the x coordinate's 1, so it's 0 over 1, so it starts at 0. So you can see that little dot there, it starts at 0. As we approach, so that's about 45 degrees. It doesn't look like it's going to turn around. Like, it looks like it's just going up and up and up. And you'd be right in saying that because if it's y over x, think about what's happening to the y value. The y value is getting really, really big. So like, in other words, the point's going up. And the x coordinate, watch it as it goes, as I go around the circle, the x coordinate's getting smaller. So it's going towards the origin. So in other words, you've got a big number that's getting bigger. So y over x. This number here is getting massive. And this number here is getting smaller. In other words, the whole number is just getting like huge. And then when you get to 90 degrees, it's massive. Like the number's sky high. And what we found out before was that tan, can you see that? Tan 90 was actually undefined. It's undefined because it's so big, but also because my x coordinate has reached 0. And also because a gradient of my point that's high in the sky is, I don't know what it is because it's so undefined. Whereas my gradients at all these points are defined. So there's like 3 reasons why tan 90 is undefined. Now at 90, so see how I'm at 90 here and the curve doesn't even look like it's at 90. There's a point there. So at 90, there's actually what's called an asymptote, which means it's like a dotted line that kind of sits. So like here's 90. The graph's just going like this. There's an asymptote, meaning it doesn't touch that ever. And then what happens is, in this little section here, so in the second quadrant, it's y over x. Y is a positive value. X is actually getting bigger. So see how it's getting bigger, but like in the minus direction. So in other words, it starts approaching 180. At 180, do we have tan 180? No, we don't, but we can look at it. I just drew on that. Here. So tan 180 is 0 over -1, which is 0, so that's why it's 0. And then I keep going around, And the same argument can be made for at 270. So at 270 around here, we've got, so remember, let me zoom in on here, 270 is this point, that's the coordinate 0, minus 1. So tan would be minus 1 over 0, which is also undefined. So that's why here at 270 there's also an asymptote. And then when I keep drawing around, it looks like that. So what tan actually looks like, or yeah, tan actually looks like all these squiggly lines that, oh, you couldn't even see what I was just drawing. Tan looks like all these squiggly lines that go like this. You still couldn't see what I was drawing. But that's what tan looks like. So I think it's kind of interesting that all of this stuff comes from the unit circle, and we wouldn't have gotten to any of it if it wasn't for, if we had our single-minded view of trigonometry as just being purely based on triangles. I hope this lesson wasn't too confusing. Please ignore the way I was working out these three. It makes more sense to do what I was doing over here. I sincerely apologize for that. I'm just looking at the questions. When you're not given something that's nice, so in other words, if this was like if you're not given something that's nice, like if this was just 121, then what you could do is it might ask you to express this in terms of something where the angle is acute. So that just means tell me what sine 120 is. Well, actually, let's just do that. So let's just do that. Let's do an example. So 9. Tell me what sine 121 is, but I want this to be acute. So that's equal to sine 180 minus 121, and that's equal to sine 59. That's it. That's done. That's you representing this as an acute angle, and you can type that into the calculator. You can type that into the calculator. It doesn't matter, but it might want you to just rewrite it as that. If it ever asks you to rewrite a trig thing, it is wanting you to use either the supplementary results, the complementary results, or these. So where these are used, you will see them a lot in proofs. So it might be like, prove that, question might just say, prove that sine 120 is root 3 on 2, something like that. This is how you do it. Can't think of anything else to say. Yes. Please, I know your interviews are today. This is your lesson for the next 2 lessons. You've got maths on Wednesday, then you don't have it till Friday. So you basically got all week to work on this. I really want you to understand it. So if there isn't something that made sense in my video, either email me, watch the Eddie Wu video, or yeah, the problem with COVID at the moment is you're probably not going to get assessed on this, which kind of sucks, but it's such a big idea in advance that it's good to understand it now. What I want to do when we get back into class is at the start of every lesson, I want to pick someone out of a hat and say, tell me what sine 45 is, and you've got to be able to tell me in 3 seconds. That's my goal. So I'd love it if if you want to make a photocopy, or maybe you want to make your own one of these. I don't know. But yeah, I don't know. All right. Goodbye.